In this video, we're going to talk about position, velocity, and acceleration, and how to get and how to switch between these states by using derivatives and integrals. So let's first start by talking about how to get from one to the other. So from position to velocity, that's going to be, you're going to need to take a derivative since velocity is the time rate of change of position. So velocity also equals dx dt, or x prime of t. Both mean the same thing. And then from velocity to acceleration, we're going to need to take another derivative. So acceleration is dv dt, time rate of change of velocity, or v prime of t, or you could express it as the double derivative of position, x double prime of t. All right, so then from acceleration to velocity, you're going to need to take an integral with respect to t. So that means the velocity is equal to the integral of acceleration a of t dt. And then similarly from velocity to position, you need to take another integral. So position is the integral of velocity v of t with respect to t. And it's also could be expressed as the double derivative of acceleration with respect to t. All right, so now let's go through a couple examples. So the first example that I'm going to go through is you're given a position, x of t, and you're told to find the velocity v of t and acceleration a of t. All right, so the velocity v of t equals dx dt, as we showed on the previous slide. So taking the derivative of this using power rule, it's going to be 2 from the exponent times 5 times t, subtract 1 from the exponent, plus the derivative of 6 times t of a constant times t is just 6, and then the derivative of any constant is just 0. So to simplify that, it's 10t plus 6. Now acceleration is dv dt. So similarly, using the power rule, we'll just get 10 plus 0. The acceleration is just 10. So now if you're given the acceleration and two initial conditions, let's try to find the velocity and the position functions. So given a of t equals 6t, and we know that velocity is the integral of acceleration, a of t dt. So that's the integral of 6t dt. And then doing the reverse power rule, we'll have 6t, add 1 to the exponent, so 6t squared, and then divide by the exponent or multiply by the reciprocal of the exponent. And then since it's an indefinite integral, we need to add a constant, so that'll be 3t squared plus c. And then we use the initial condition here to solve for the constant. So v of 0 is, so we'll plug in 0 for all the t's, so 3 times 0 squared plus c equals 12. So then we get that c equals 12. So then v of t equals 3t squared plus 12. That's our answer for velocity. And then for position, we have x of t equals the integral of velocity v of t with respect to t, which equals the integral of 3t squared plus 12 dt. And again, using the power rule, we'll have 3t cubed over 3 plus 12t plus c. And then again, to solve for the constant, we'll use the initial condition that we're given, x of 0 equals, so these 3's cancel out, so it's just t cubed, which is 0 cubed, plus 12 times 0 plus c equals 9. So we have c is 9, so then x of t equals t cubed plus 12t plus 9. All right. Example, we're given a velocity v of t, and we're asked to find the acceleration and position functions using the initial condition given. So let's first find acceleration. So v of t equals 14t plus 9. So the acceleration, a of t, equals the derivative dv dt. So that equals, using the power rule, or just taking the derivative of any constant times the variable we're taking the derivative with respect to. It's just that constant, so the acceleration is just 14. Doing the position, x of t equals the integral of velocity v of t, so the integral of 14t plus 9 dt equals 14t squared over 2 plus 9t plus c. So that simplifies to 7t squared plus 9t plus c. And then using the initial condition, we have x of 0 equals 7 times 0 squared plus 9 times 0 plus c equals 3. So these both go to 0, and we're just left with c equals 3. So then our final answer, the position function x of t equals 7t squared plus 9t plus 3. All right, so those are the examples. One, given position, acceleration, and velocity, and going between the 3 different functions. So I hope that video helped. If you have any other suggestions for future videos that you would like to see or other examples that you want to see, please leave them below in the comments. Thanks for watching.